3, 2, 1, drop. Three, two, one, action.
Hi, I'm Andy, and recently I had the massive honour of coordinating the full action sequence for Red Bull when they revealed their 2026 Formula One car. Amazing project, you might have seen it online, so much went into it. So what I wanted to do now is just break down how we did it, what went into it, and just really give some credit to some of the people that were involved in this massive project. So obviously the project got revealed a couple of days ago. Everyone's going nuts for it online. A huge, massive thing for me to be involved in. I've been working with Red Bull on lots of very similar huge projects over the years, but this was one where they kind of gave me the full sort of like control over the project and said, this is what we want you to do. Go away and tell us how we can do it safely. Do some tests, do some rehearsals, pull the project together, and then we'll come out and film it when you say it's all good to go. So yeah, let's take it on board. So the idea originally came around when Toby from Red Bull, who I've worked with for a number of years and is an absolutely wonderful person to work with because just the trust he has in me to do this super cool shit I get to do. So Toby says, we want to have an unveiling of our new Formula One car. How can we unveil it? We want to have some sort of Red Bull involvement. Red Bull, we don't do things, small. So we're going to have one of our aircraft involved in doing it. So had a chat with him, had some ideas, went and looked at some locations. We're working out how we can do something of this scale. We then thought, well, Martin Sonka is a stunt pilot for Red Bull, ex-fighter pilot. He's going to be able to do what we need to happen. So I've now got to work out the methodology and the design of the stunt to make sure it would happen. So Toby handed it all over to me. I'm thinking to myself, right, what can I do? So the first thing I do, I actually get some toys. I get a toy car and I put a napkin over it, and I get an aeroplane and I just play around with it. And I think, how can this reveal a Formula One car? But Formula One and Red Bull, it's about speed and precision and aggression as well. I want it to unveil it like bang, just really like rip the cover off. So I start thinking of a few ideas on how we can do it. Now, I then reach out to Peter. Peter's someone I've worked for a number of years. We used to work together on Top Gear, and he's a very skilled engineer who I can go to and say, Peter, I've got this kind of idea, but what's the engineering behind it? I need a way of hooking something on an aircraft, some sort of hook that can rip a cover off of a plane. Now, I started researching how the banner planes would work in America. You might have seen the planes that go down a beach with the whole, will you marry me banner out the back. But they do it a lot slower. They just chuck a hook out. They go down almost at stall speed and they chuck a hook out the back. That hook picks up the banner and away it goes. But it's not impressive, it's not fast, it's not got aggression. So I go to Peter and I'm like, we need some sort of hook on the aircraft. We want this shot. And this is where Toby and Nacho and a lot of the team at Red Bull were like, we want this shot where the plane and the car are together, tight, and showing the Red Bull, the wording on the wings. How can we make this happen? So Peter and I then worked out a design where we actually had some sort of hook on the rear of the aircraft that could pick up sort of like an arrestor cable, like a fighter plane would have on an aircraft carrier. And we work out this design, but then we think in an emergency, we need to be able to jettison the hook off the back as well. So we work out a way that we can pull a cable, and that then releases the sheet that's going to be over the car. But at the same time, then we've got to think, well, this sheet can catch. A Formula One car is designed to go this direction. And throughout the whole project, I wanted it where I wanted the car facing one way and the plane at the same way. So as the plane pulls up, you've got this combined shot of a car and a plane. So it has to be in the same way. So when you look at the way a Formula One car is designed, there's a lot of very sharp edges and sharp points, especially towards the rear of the car. So we started thinking then, well, what can we do? How can we do this? So immediately we thought of balloon material. So Peter introduced me to this company called Cameron Balloons, and they started making us up some test sheets to go over the F1 car. But then we realised if we're going to have a plane at 200 kilometres an hour, ripping this cover off a car, it's just going to rip it. So we had to then put some carefully designed webbing underneath the car cover that you can't see, so it would dissipate that shock load and that energy as we ripped it off. So we started doing that. We had some test sheets. We then went to the Red Bull factory. They had a spare massive hanger that we could use, and you'll see some of the tests that we did there now.
So this is a 6x4 test at 45 degrees with a 4 metre drop. Now, we're going to do a Newton metre test on this one, test for peak load. What we've done is as well, we've actually scrunched up sides of it to actually create a bigger air gap around the bottom, because we're realising that the bigger air gap we get, the less suction it creates. So we can suction that up. That's going to go around there and it will pull itself out as we go. So, everyone ready? Okay. Weight bag at 4 metres, extra suction, gaps around the bottom. And 3, 2, 1, drop.
So after those tests, we realised that the actual concept of how we can rip something off a car, it does work, and we can do it without it catching. The good thing as well, Cameron Balloons designed this sheet covering material to have like a synthetic ceramic coating almost to it. So it just really gently like slide off and wouldn't catch. Massively lightweight. The thing to consider is our sheets were down to 3.8 kilos in the end, but that 3.8 kilos when you're catching it at 200 kilometers an hour is quite an impact. So we had to design lots of ways where the sheets would do this, and there's a problem with vacuum as well. Vacuum causes suction, so when you're sucking something off a car, the initial phase where we actually thought, well, we might suck the car into the air. So then Peter had to make some plates that we would put down to actually secure the car to the ground with that. So whilst we were doing this, I'm now working on the sheet and the design and how the choreography and the coordination of the stunt could happen. Peter goes out to the Czech Republic and meets up with Martin. So this is our now first instructor, Martin Sonka. I fly myself. I'm still not qualified. I've only logged 32 hours, but it's something I love doing. I love flying, and I have a massive passion for military aircraft and especially fast jets. So to work with Martin, who's an ex-fighter pilot, for me is just, you know, a massive honour. Where I'm working with an ex-fighter pilot and someone who's a stunt pilot for Red Bull, massively experienced pilot. Yeah, that was pretty cool. So Martin and his team, Sonka Aviation, he's got an amazing team behind him. He's got this stunning, absolutely beautiful hangar where his aircraft are. So Peter would go out there, and Peter was then working out how can we attach this hook system to Martin's aircraft. So we're working out all of that and how we can do all of that. So we developed this hook system, but then we don't want to put it straight on the aircraft and start testing because it's doing 200 miles an hour. If something goes wrong, that's dangerous. We want to actually test it on the ground. So that's then where, ironically, my son is a racing driver. So we got him on board and we got a van and we replicated the rig that we were going to put on the back of the aircraft. We replicated the wire system which we were going to stretch across, and we got my son to do a couple of runs past at speed to actually understand how the system would rip off of a Formula One car and how it could then eject it later on as well. We even got a load of traffic barriers to actually make the shape of a Formula One car. We did it on the back lot of Shinfield Studios where I've got an office, and you'll see some of that footage now of the testing that we did to make sure that it would work. The theory is if something goes wrong on the ground, we're doing 50 miles an hour, we're in a van and we're doing, you know, we're on the ground. Great. We want things to go wrong there. We want to learn from it, because what we don't want to do is learn from it when it's up in the air at really fast speed. And you'll see some of the footage of those tests now.
So this is the modified hook with the spacer on it, 45 miles an hour, 1.8 meters high, 12 meters that way. Hayden, in your own time. 3, 2, 1, action. And eject, eject. Spot on.
Go guys.
And stop, stop, stop.
So once we did those tests, we've then got a load of Newton meter readings from the sort of forces that can be put on the aircraft. And we've got some measurements as well, what happens when we pull a sheet off at speed and the measurements behind it. And I'm thinking to myself, right, I need to speak to like a structural engineer or some sort of aerodynamic people that would understand wind and speed and how things move through the air. And I'm thinking, who can I speak to? And then this light bulb moment is in my head. I phone up Toby from Red Bull and I'm like, Toby, the project is for Red Bull Formula One. They're the greatest aerodynamicist people in the world. So Toby rigs this meeting up for me. And I'm a massive fan of Red Bull, okay? Love Formula One. Red Bull's my favourite team. So, you know, the project is going pretty cool already. I go to Milton Keynes to the factory and I meet this guy, Andy Danarum. Turns out he's the head of Red Bull Advanced Technologies and he introduces me to Dan Smith, who just so happens to be head of aerodynamics. So we go through all this information and there's me with like a load of weights and drawings I've done on my iPad and toy planes and stuff. And I'm dealing with Red Bull's aerodynamics team. So they chuck a load of this information, this data, which I've got into their CFD, computer fluid dynamics. And they can model and sort of like do very, very clever scientific measurements and modeling on this. As you've probably guessed, this isn't really my forte in understanding aerodynamics. So what's super cool is I've got the team from Red Bull working out and backing up the calculations that I've made to see if what we're doing can happen. So we get all these aerodynamic readings and these figures and these like kinetic energy loads. And then from that, they say, yeah, this can be done. Amazing. So next step, we go back out to Prague. We then drive across the Czech Republic, amazing place, absolutely love it out there. And we go to this airfield, meet up again with Martin, and we then start doing some tests. Now the initial tests we did, we don't want to do it straight in a Formula One car. We want to do it on nothing to start with, just to make sure that what we're doing works. So we've done around 55 tests in the UK now. Now we're actually going to start doing it for real, on a plane, at speed. So Martin does a few runs, he comes down and we start off just by lifting a sheet off of nothing. It's just on the floor. I think we did like a 4 metre by 2 metre sheet and you'll see that test here. So once we've done that test, we're thinking, okay, screw it, let's do it. Martin's happy, and that's my main priority, making sure that Martin's happy what we're doing. No one knows more about the risk and the reality and the danger of what he's about to do. So my role then is to make sure that everything is in place before we hand it over to Martin. We go to the airfield, camera team come out, we then work out how we're going to film it, we brief everyone, and it's like another big part of this is we want to do it as minimum times as possible. It is risky, it is dangerous. Martin is doing huge G-forces, 200 kilometers an hour. It's big. So we get the car out there. Here's the other thing, the car. No one has seen the car. It's a massively secret car. It's a secret reveal. No one knows what it looks like. So I've now got to think, well, hold on. We've now got to do the test again on the car to make sure nothing catches. So you'll see some footage now of another test we did just before we started then chucking the plane at it at speed.
27.5 kilo on there, going up through the system. Angle is 28.2 degrees of angle. Everyone ready? 3, 2, 1, release.
I'm now happy. Martin's happy. Let's do it. Go to another airfield. All the camera team are there. We set it all up. Car, sheet. We have a load of special vents built into the sheet as well to dissipate the vacuum that's going to cause suction as it pulls off. We used carbon fibre fishing rods to hold the arrestor wire up in place. And what's interesting with that wire that's across there that goes to the sheet is we couldn't have a sudden shock loading because that then puts a shock and a stress on the airframe. So what I did was a couple of weeks before, I went down to Southampton, which is, for those of you that know Southampton, it's got quite a big sailing community there. And I started speaking to a few sailors on how things work and on how the spinnaker sails on the front of the mast get unfurled and don't snap a massive carbon fibre mast. And I went to a place called Force 4 Chandlery, and they were really helpful. And we basically got some shock corded wire, which can take a 2.5 ton shock load. And what we did was we did 4 meters of that shock wire, and that enables us then to then swoop down, catch the sheet, pull it off the car, but then absorb that sudden massive impact that that sheet, that wind sail effect is almost making. It extends out. And then what's really, really cool, and the whole point of the project was speed, precision, but aggression and this like instant power. So when you see the plane go down and pull away, the sheet just expands out from that arrestor wire, and then you just see it go bang, and it's just such a fast reveal. We were even worrying at one stage that it would be such a fast unveiling of the car that the camera angles and the frame rate that we were using wouldn't actually be able to pick it up. It would just rip it off so fast you'd see car and then you wouldn't see car. But luckily that all worked all good. So we've got the sheets on there. We do the stunt a few times. Perfect. We've got the shot. Anyway, it all happened. Everything went well. The reveal came out 2 days ago. Everyone's loving it online, which for me is amazing. I'm looking through the comments and it's super, super cool. The client's happy, great. So there's so many people that need to be thanked for the involvement in this. There's the MSS safety team who project managed it behind the scenes, booking flights and equipment. Kelly from our team was driving all over the place, picking up things that we needed. Martin and his team, you know, as I've said already, working with a former fighter pilot that is this amazingly skilled pilot, and the trust that he put in me and I put back into him, yeah, that was pretty cool for me. Absolutely loved it. Peter and Luke and the guys that did all the engineering behind it, the guys from Red Bull, Nacho and the whole guys that were that directed the project. And then I suppose the massive final thank you is to Toby and the guys at Red Bull for just doing what Red Bull do. Red Bull don't do things lightly, and what they created here was so cool. So for Red Bull to kind of say, let's do something big for this is brilliant. And what's even better as well is the fact that there's a lot of other teams going to be releasing their Formula One cars in the days ahead. They've got their work cut out because they're just going to pull a sheet off and go, there it is. Look at what Red Bull's done. It's amazing. So there you go. That's just a little bit about the behind the scenes, how we did it. And I really want to share some of the test footage that we did to show you what's gone into a project this big. And finally, just to say it again, massive thank you to Red Bull for just doing what Red Bull do. They, yeah, as I saw in one of the comments, we want to unveil a Formula One car. Hold my Red Bull, watch this. Brilliant. So there you go. Anyway, thank you very much. Hope you've enjoyed this little explanation of how we did it and some cool behind the scenes content. There's going to be a link below where you can see the unveiling film again. If you haven't seen it, watch it again. I've delayed this video for a couple of days because I wanted all the proper official behind the scenes and everything to come out, and obviously the main reveal film as well. But I just wanted to share a bit of involvement in it and just to say thank you to the people that made projects like this happen. Anyway, I'm Andy. It was an honour for me to be the action coordinator for this project. Absolutely loved it. And thanks for watching.